Okay, today I'm going to show you how to calculate the change in entropy for the following chemical reaction. We have methane gas combining with or reacting with oxygen gas to produce carbon dioxide gas and water vapor or water gas. Now, as you can see, this equation is not balanced because we have 4 hydrogens here and we have only 2 hydrogen atoms here. We also have 2 oxygen atoms here, but we have 2 plus 1, that's 3 oxygens here. So the first thing we're going to do is to balance this equation, and the easiest way to balance the equation is to take inventory of how many atoms you have on this side compared to the number of atoms on the product side. So I usually do this. I draw a line in the middle of the arrow. These here are what we call the reactants. Okay, these are the things that are reacting, and these here are what we call the products. Now, let's say we have 1 carbon on this side and we have 1 carbon on this side. So the carbons are balanced. We have 4 hydrogens on this side and we only have 2 hydrogens on this side. So the hydrogens are not balanced. We have 2 oxygens on this side, on the reactant side, and we have 2 plus 1, 3 oxygens on this side. So the oxygens are not balanced, just as the hydrogens are also not balanced. So to balance the equation, we use the smallest coefficient. So let's start by putting a 2 here. Okay, so now that means 2 times 2 is 4. We have 4 hydrogens on this side. So now the hydrogens are balanced. But that gives us 2 oxygens and 2 oxygens, 4 oxygens. Because this number here, the coefficient is standing for both hydrogen and oxygen. Okay. Now let's see what can we do here to balance to make the oxygen 4. We just put a coefficient here, a 2. So now 2 times 2 is 4. Now that we have the hydrogens and oxygens balanced, we can calculate the entropies. So we go to the table of entropies, and on the table of entropies, the tables are found at the back of every good chemistry textbook. Also, you can search one from online. You can download the table of entropies. Okay, each compound, each element of entropy numbers that have been calculated by scientists. So we just have to look them up, and if we look on the table, we find that the entropy for methane gas, okay, we always have to look for gas. The entropy for methane gas is 186.3. I'm not putting the units now, okay, because the units we'll put them after the calculation. I'm making it simple for everyone who is learning chemistry. First, we can just work with the numbers. And the entropy for oxygen gas is, I'll just write it here, is 205.2. Okay, again, these numbers are found from the textbooks. And we can also put the entropy for carbon dioxide gas is 213.8. And the entropy for water gas, okay, we always have to look for gas because water can also be solid, can also be liquid, and all the entropies are different for each. So when we're looking on the table, we make sure we look for the one with the G. G for gas. Okay, the entropy for this one is 188.8. Okay, now these are taken straight from the table of entropies. Now, the next thing we're going to do is we're going to make sure that this one, the entropy for oxygen, we multiply by 2 because of this number here. Okay, so we say times 2. Similarly, we're going to multiply this number here by 2. Okay, we have to make sure that we do that. Now, this 2 times 205.4 gives us 410.4. Okay, and this number here, when we multiply by 2, we get 377.6. Okay. Now we're going to take the sum. We're going to add up with this number here. Okay. Similarly, here we're going to add up with this number here, because we want to find now the sum of entropies on both the reactants and the product. So if we add up this number here, we get 7695. Yeah, 7695. And this one will give us 4.195. So that's this is the entropy, the sum of entropies. If you want, we can put the units now, per mole, and now the next thing we're going to do is to calculate the change in entropy, and we'll use the formula change. Delta stands for change in entropy, and S is the symbol for entropy, equals the entropy of the products. Okay, entropy of the products, which is this number, minus entropy of the reactants. It's a simple math. So the products is 591.4 minus 596.7, and the final answer is minus 5.3, and that will be J/K. So that's the answer. So you can see by just looking at this equation, it's difficult to predict whether the entropy is increasing or decreasing, because they are all gases, and the number of atoms on each side seem to be the same. So you can't just predict whether entropy is increasing or decreasing until you do the calculations. And from these calculations, since we now have delta S is a minus, we can say the entropy is decreasing. Okay, although we are not asked about this, but entropy is decreasing. Is decreasing. Okay, so what does that mean? It simply means as you move from this, as you combine, as methane and oxygen combine, the entropy is increasing. It is decreasing. It's not increasing, but it's decreasing because delta S is a minus. We found a minus 5.3. So it's decreasing. So this is how you calculate the change in entropy. The common mistake that students make is once they balance the equation, they forget to multiply this by the coefficient of the numbers that the compounds that they balanced with. Always make sure you multiply with the coefficient, the entropy of that element. So this is the easiest way to calculate.